Welcome back, my dear students. I hope you have seen lesson 1 in which we studied the basics of an altimeter and what is QNH, QFE, etc. and how to calculate the actual climb when the set heading is on QNH and top of climb is in 1013.25. We bring them to both to the same datum and then check the vertical distance and also how to find out horizontal distance during climb. Right now, today we are going to continue further from the previous lesson, and SK Booty is back with you for the next lesson, continuation lesson. Today we are going to study the corrections for various errors which occur in an altimeter. The altimeter is calibrated on a standard lapse rate of 1 HPA, that's a pressure lapse rate, 1 HPA every 30 feet. The actual lapse rate in the atmosphere will depend upon the actual temperature density conditions, and hence your altimeter shows you only an indicated altitude. That's not the true altitude. The performance of the aircraft depends upon the density altitude. Then how to find out the density altitude, and how to find out whether your altimeter is under reading or over reading. That's what we will study today. First of all, for the temperature error correction, this is used to find out the true altitude from the indicated altitude on QNH on your altimeter. And temperature error correction, we first find out what is the ISA deviation at the altitude at which we are flying. And the deviation is outside air temperature, also called still air temperature, also called ambient temperature, minus temperature in ISA conditions. Same deviation is used for density error correction also. To find out temperature under ISA, temperature ambient, you read from your thermometer gauge fitted in the aeroplane and apply the correction for if there is any correction for friction rise, and you get the still air temperature outside. In the examination, SAT will be given to you. SAT minus the temperature under ISA conditions at that altitude. Temperature under ISA can be calculated as plus 15 minus the fall of 1.98 or 2 degrees per 1,000 feet. For example, at 10,000 feet, temperature should be plus 15 minus a fall of 10 into 220 degrees, that is minus 5. If outside air temperature is minus 10, then the deviation is minus 5. That is how we do it. T ambient minus in bracket T ISA. Right? For every 4 degrees, for every 10 degrees ISA deviation, we apply a correction of 4% of indicated altitude to get true altitude. Here, since the deviation is 5 degrees Celsius, we will apply a 2% correction. If deviation is minus, subtract this correction. If the deviation is plus, then add this correction. In warm air altimeter, under reads, true altitude is more. So here, since my correction is minus 2%, then 10,000 minus 200, my true altitude is 9,800 feet. to find out the density altitude from the pressure altitude, and this correction is applied to pressure altitude. Temperature error correction is applied to indicated altitude on QNH. Very simple. Pressure altitude plus 118.6, or we round off this value to 120 into ISA deviation. Okay. Now find out your pressure altitude, which will be given to you, and then apply this correction. If deviation minus, this value will become minus. If deviation is plus, this value will become plus. Under high temperature conditions, this value will be plus, and your density altitude will be higher. And when your density altitude is higher, more than pressure altitude, it means the density at your altitude is low. And this low density should have occurred at this density altitude, which you have corrected. So high density altitude, which means low density at your altitude, had adverse effect on aircraft performance. Your rate of climb will be less, fuel consumption will be more, time you can fly and the distance you can fly within a given fuel will be less, takeoff and landing distance will be more. That is called adverse effect on aircraft performance. Next, how is the barometric error correction applied, and what is it? Barometric error correction happens when you have set your altimeter window, that's a datum pressure, to some other pressure, but actual pressure where you are flying is less or more. And then there is a barometric error. This we will read after 2 minutes. When you are flying a flight level, your altimeter is set to 1013.25. Okay, understood. And he says you are flying at flight level 80. Okay, my indicated altitude is 8,000. Now, he says you're crossing a hill of 7,000 feet. What is your separation from the hill? Is it 1,000 feet? That would be 1,000 feet, since my altimeter is reading 8,000. If I have set this pressure here, prevailing pressure, on my datum. Since my datum pressure is high, actual pressure is low, high, low, high. My altimeter will read high, which means it will overread, and difference is 10 millibars. So it will overread by 300 feet. When it is overreading by 300 feet, indicated is less. That is the reading. And true altitude, indicated is 8,000, but my true altitude will be less. Indicated is more. So my true altitude will be 7,700 feet. And answer that you are crossing this hill by 700 feet. Take the case of another aircraft on another day. He is flying on an QNH of the takeoff, and he is flying on the same setting. Okay, find out what is the altimeter set to datum pressure. If he is flying on QNH, which is given you 995, write down 995 here, and find out the actual pressure over here, if it is not given to you directly in the exam. If place A, you are going to place B. Read the QNH at A, read the QNH B. A plus B divided by 2 will be the QNH midway, if this hill is midway. So calculate the pressure, actual mean sea level pressure, midway in this case. Right? And you have calculated that the actual mean sea level pressure at this place is 1015 HPA. Since altimeter setting is low, but actual pressure is high, low, high, low, my altimeter will read low or under read. Difference is 20 millibars, 20 to 3,600 feet. Okay. Now, in this question, if he is given you what is your altimeter indicating, then find out true. But in this question, if he tells you that I wanted to cross this hill by 2,000 feet, okay, now my true altitude becomes 9,000. Then he could ask you on what altimeter reading, at what altimeter reading will you cross the hill with 2000 feet margin? So my true altitude should be 9000. In the first case, aircraft was at flight level at 80, that is 8000 feet was my indicated reading. Here he says what altimeter reading, that means he's asking you this reading. Then he'll tell you what should be your true altitude. He says, okay, cross it by 2000 feet. So 7000 is hilltop plus 2000, 9000. And at 8400 feet altimeter reading, I will cross this hill by a margin of 2000 feet. So this error which I apply, one is the barometric error, which we have now calculated. And if there is a instrument error, don't forget to take that also into account. What is an instrument error? At the time of takeoff on QNH, your altimeter should have read the aerodrome elevation. Now here, in this case, if I read, my altimeter due to barometric error is under reading by 600 feet. So write down here 600 feet under reading. Okay. Now I enter here that my altimeter due to the barometric error is under reading by 600 feet. Now, if he tells you that at the time of takeoff, elevation is 300, but your altimeter was reading 330 when set to QNH. Not to worry, that means I have an instrument error. And instead of 300, my altimeter is reading 330, and it is 30 feet over reading. Now, if both are under reading, add, both are over reading, add. Now, one is under reading, one is over reading. So my net result will be 570 feet under reading. So apply a correction of 570 feet in case there is an instrument error also. Then apply this correction here and also here, whichever is the case, to find out. Here we were doing this particular case. This was under reading, this was over reading. In first case, if this was similar case, altimeter was over reading by 300 feet due to barometric error. Okay, 300 feet over reading plus 30 over reading, then total over reading becomes 330 feet. Then apply the value of 330 here. Over reading by 330 feet, indicated is 8000 minus 330 will be your true altitude. Barometric error corrections are very common questions. Indicated is there, you can find out true. If he says this should be your true altitude, where he gives you a restriction, then find out, he might ask you what is your indicated altitude. And the correction here we apply is a combination of barometric and instrument error, and we apply a correction of net error. Fine. In lesson number 8 of altimeters, I have given you different types of numericals for your practice. Do solve those 10 numericals. And in case you have any problem, write in the comments, come back to me, and I will tell you where you are going wrong. In lesson 8, I have given you questions and answers. Here I have given you only one question along with the answers. Lesson 8 will be for your practice. And don't forget to complete these numericals. In this question, he says aerodrome elevation is 1350 feet. Okay, here it is. QF is 950. Actual lapse rate is 1 HP every 27 feet. But the standard lapse rate, as you know, is 1 millibar for 30 feet. Pressure where the aircraft is flying is 840 HPA here at this place. He wants to know what is the height. Height is from here to here. QFE minus the ambient pressure into 30 is your height. QNH minus the ambient pressure into 30 will be your altitude. And if he says, what is your pressure altitude? Then pressure altitude is 1013.25 minus ambient pressure into 30. So this aircraft pressure altitude will be 5198 feet. We don't use QFF in altimeter. It's basically a MET question, but in case he asks you what is the QFF, then it will be QFE plus aerodrome elevation divided by the actual lapse rate in existing conditions, which is given you that today actual lapse rate is 1 HPA every 27 feet. And 1350 by 27 plus 950 is equal to 1000 HPA. And that is your QFF. When lapse rate value is less than 30, that means the lapse rate is high, the pressure is falling every 27 feet. And lapse rate is high generally in cold conditions. Pressure is high, lapse rate is also high. So when there are cold conditions, your QFF will be more than your QNH. That's a theory question. In numericals, altimeter numericals, we use the value of QNH, which is calculated under ISL lapse rate of 1 HPA every 30 feet. So these are some of the numericals for your practice. As you practice some more and practice numericals in lesson number 8, which I have given you, I'm sure you'll be able to solve any numerical from any book. And all the numerical question banks which I have given you in subsequent lessons, at some places I have given you also the hint with every question. At some places I have left it to you that, okay, now do these questions and then check the answers on the next slide. So be true to yourself. Don't look at the answers before you do these questions, and success will kiss your feet. That's my promise to you. Good luck. All the best. Happy landings. And before going off, how about taking 10 seconds and pressing the like and subscribe button? Thank you. See you next time with the next lesson.